C. This is the second last chapter that we'll be examining. Last lesson we were looking into obviously our Venn diagrams and two-way tables, and today we're focusing on 8C. Now, in terms of a learning intention, what I want us to try and understand today is this addition rule. Okay, you may have never heard it before, but just understanding the addition rule and the probability of the union of two events. So remember union, so when you have like A union B, what is the probability of this thing occurring? Okay, the union events. And also know the notations for and, so and or, okay? Those are the two different notations that you'll be seeing for and or. And as a success criteria, we're going to try and apply some of this to some unknown probabilities. So what this is pertaining to is using a little bit of algebra, okay, to figure out some unknown probabilities, and then recognize that and corresponds to intersection, so intersection, and or responds to union. Just understand that. Okay, and responds to intersection, and or corresponds to the union. So these are the two main symbols that you'll probably be seeing often. Okay, you don't have to write the learning intention and the success criteria, but just know that they're there, and that's what we're focusing on. Okay, so I want to, I guess, see how we go with this. We don't have to fully discuss it together, but maybe with the person next to you, I want you to consider the following scenario. Okay, a group of 18 CS locals were asked whether they shopped at Coles or Aldi. So already we know that the universal is 18, so altogether this should add up to 18. Shopped at Coles or Aldi. 10 said they shopped at Coles, and 12 said they shopped at Aldi. Okay. Now, thinking about the universal set being 18, so when you add everything up, it should equal 18. Okay, and you have 10 that said they like Coles. You have 10 out of 12 like Coles, and then 12 out of 18, 12 out of 18 liked Aldi. Does this make sense? Are they mutually exclusive or are they not mutually exclusive? They are, they're not?
They're not.
They're not mutually exclusive. All right. Okay, Lily, can you tell me why it's not mutually exclusive?
Because they don't add up to 18.
Good. So when you add them together, it actually equals 22 out of 18. So that doesn't make sense. Where's that extra 4 coming from? Anyone know where the extra 4 would be from? Neither. Could be. But have a think. They both shop at somewhere.
Or some go to both.
Some go to both, which means it's the intersection. Okay, some of them are in the intersection. So, because there's an intersection, that means this is not mutually exclusive. What might the Venn diagram look like? Well, let's draw it really quickly. Okay, so you've got Coles and Aldi, and then the universal is 18. That looks really bad. And we don't know, okay, exactly how much shop in both, but at least we know that altogether in Coles, there are 12. Okay, so there's 12 in Coles. Okay, and in Aldi, there's 10. Okay, now it being that the case, we know at the same time that 12 plus 10, so if you go C plus the A, which equals 12 plus 10, you get 22. Okay, but we don't know what goes in the middle. Okay, so we'll have to figure out, eventually what we're trying to learn is how do we figure out what's in that middle. So if you actually go back to that CFAT that we just did, some of this might have been useful, but that's okay. Okay, so we know that there's 4 extra numbers there. So we know that the universal should be 18, but there's 22 for some reason. Okay, so there's an extra 4 numbers. That means generally those 4 extra numbers will go in here, and that's how we'll figure out, this lesson is all about figuring that out and how that all works. Okay, so technically if I was to do this, if there was 4 in the middle, okay, I figured that out because there's 22 altogether, but there should only be 18. That extra 4 goes in the middle, and then from there I can now figure out what goes in C. So I know this all equals 12, so that should be 8, and this all equals 10, so that should be 4. Okay, but we'll leave that at, sorry, I said that wrong, 6, my bad. Can't even add, equals 6. And then when we put all that together, 8 plus 4 plus 6 will equal the 18. Okay, so that makes sense. But there's additional rule which we'll be using to figure that out. Okay, so this is what you'll want to write as your notes, guys, for an additional rule. Now, you don't have to necessarily draw this, but I would like you to write at least this little rule. So this is additional rule for not mutually exclusive. So this is your additional rule for not mutually exclusive, meaning that there's an intersection in the middle. Okay, so I just want you to actually write just that. Just this bit here. Oops. Just this. Focusing on that. Okay, you'll be using this rule often in order to figure out some unknown values. Yeah, so if you read what the rule is saying, PR of A union B, so when you're looking at the union, to get the full probability of the union, you're going to go all of A, so all of A, plus all of B, minus the intersection. Okay, that's what that's saying. And what happens is, when you do that, the reason why you minus the intersection, okay, is because if you add all of A and all of B, it equals, like what we saw before, just really quickly, it equals more than the actual universal set. So we have to take away a certain number. And that certain number we take away is actually the intersection. So this, we're taking away that intersection. And what that gives us, okay, is the probability of everything within A and B. Okay. Okay, and similarly, and we should know this, if the mutual events are mutually exclusive, so I want you to copy this down. So this is the additional rule for mutually exclusive events. So you don't have to copy the Venn diagrams, but at least copy that rule. And we're working with probabilities, by the way. So what this is saying is, if you have a mutually exclusive event, and you want to figure out the probability of A and B, but then they're mutually exclusive, so no intersection, it's just going to be all of A plus all of B. Notice how we don't take away the intersection, because there is no intersection here. Okay, there's no intersection for this one. So we don't have to take it away, because it doesn't exist. Okay, so those two rules we're going to work with today and try to understand them as best as we can and see how they apply to probability. So this is basically kind of like algebra in some sense. Okay, in some ways it's kind of like algebra, and we'll see why in a second. So let's move on. Everyone got it? Can we move on? Okay, let's move on. If you missed out, don't worry, the video will be on OneNote. So challenge for you guys. If I wanted to figure out what is the probability of these three, I don't know if we're going to spend too much time on this, but can anyone think of the rule for figuring out the probability of these three? So if you look at previously, you can see that when we're looking at the probability of two circles and they have an intersection, we're always taking away the intersection, yeah? So if you had one for this, with three circles, what do you guys think it might be? Any clue? Yep, Michelle? Yeah, so you're going to take away this. What else? Would you take away anything else? Good, the other three around it. So as a rule, this would actually be really annoying. If you were at PR of A union B union C, it would look like this. PR of A plus A, yeah, you get PR of A plus PR of B plus PR of C, but then you'd be taking away a few things, minus PR of A intersection B intersection C. So that's the first one there. Then the next one would be minus PR of, annoying, A intersection C. So that would be this. Okay. And then the next one would be minus PR of B intersection C. You don't have to write this. I don't know why they included this. Minus PR of B intersection A. Okay, those three. Now, we're not going to do any questions that has this, okay, because it's not really relevant in year 10, but just something for you guys to know. But just know that in a mutually exclusive event, non-mutual, just understand that we have to, we take away that intersection there, yeah, for the rule. And you can see it here. All right, let's move on. And versus or. So what is the difference between and or? Okay, so when probabilities involve the word and, then we use the intersection. Okay, so the word and the intersection are pretty much related to each other. So if I told you Venn diagram, okay, you've got that A, B, you might have 1, 2, 3. What is the probability of A and B? Okay, and just means the intersection. Okay, right there. That's what it's referring to. Okay, an example here. What is the probability of tossing 5 and an odd number on a dice? Okay, so 5 and an odd number on the dice. So the word and, okay, right there is used with that symbol there. So PR of 5 and odd. Okay, that's what that basically means. So you can see that these are actually two separate events, and that's what we're kind of getting into later on. When you have two events happening, what might that look like? Okay, or. Okay, slightly different, but with or, we use union. We use the union symbol, okay, for or. So going back to my actual example here, what is the probability of a union B? So this is saying or, so anything inside the circles, or. Okay, so A union B would be 6 out of 6, for example. Okay, for the union. So or tends to have higher probabilities than and. Okay, and an example of that is PR of tossing a 4 or an odd number. Okay, so union refers to the word or. Okay, so some examples here. A card is drawn from a pack of 52 cards. What is the probability that the card is a heart or a club? Okay, a heart or a club. Well, first things first, let's figure out the probability of actually getting either. So what's the chance of getting a heart card in any deck of cards? Anyone know? Hearts, deck of cards. 13 out of 52. Yeah? Or you can simplify that as 1/4. Okay? And chance of getting a club is also 13 out of 52. So that equals 1/4. So the addition rule for mutually exclusive events. So remember that, the addition for mutually exclusive. So if we're going to go PR, what's the chance of getting either of these, a heart or a club? So PR of a heart or a club, I think club is the one with 3, is going to be the probability of a heart plus the probability of a club. Okay, and then using algebra, all we do is just replace these symbols. So it's going to be PR of heart or a club. It's going to be PR. So getting a heart would be 1/4. Plus getting a club would be also 1/4. And that equals 1/2. Or 2/4. Let me not simplify it just yet. Equals 2/4, which is a half. So that means the probability of a heart or club would be a half. Does that sort of make sense? So if in a deck of cards, the chance of you getting a heart or a club is 50%, basically. Okay, that's what that's saying. All right, that's exactly the same thing. So let's try this one here. A dice is rolled, okay, and the set of possibilities are 1, 2, 3, 4, 5, 6, obviously. So what is the chance of getting an odd number? Okay, what is the probability of obtaining an odd number? Well, let's have a look. So PR of odd. I can see that in any dice there are 3 odd numbers. Oh well, there's 3, 5, and we'll say 1 is an odd number, it's prime number. But we'll say it's an odd number too. So that means you've got 3 out of 6. So there's a 3 in 6 chance, simplified to a half. What's the probability of getting a number less than 4? Less than 4, okay, well, let's have a look at the probabilities here. 4, I believe, is not included. So less than 4 would just be the first 3 numbers. 3 out of 6, which is also a half. Okay, so what's the probability of getting an odd number or a number less than 4? Okay, now remember we use the rule for a non-mutually exclusive because this would have, if you think about these events, they both have something in common. Okay, less than 4, so if I write this one here, odd, all the outcomes for the odd numbers are 1, 3, 5. But for all the less than 4, you've also got 1, 2, and 3. What do they have in common? Well, they have 1 and 3 in common. So that means these are not mutually exclusive. Okay, so the rule, remember, for a not mutually exclusive is this one here. So if they're not mutually exclusive, we're going to use this rule. So let's look at that rule. Okay, symbols are going to be crazy for this one. So if we use the rule, probability of, let's go odd union less than 4. It's going to be PR of odd, plus PR of less than 4. Take away, now looking again at the rule, what do we take away? We take away the intersection. Okay, minus the intersection. Minus the PR of odd intersection less than 4. Okay. So what's the chance of getting both of them, either or? All right, so probability, I'll write it again, odd. I know this might be a little bit dry and you might not understand it, but rest assured if you keep trying it, you'll get there. So probability of getting an odd is a half. Oh, we'll just go a half, sorry. A half plus less than 4 is also a half. Take away. Now, in terms of getting the intersection, sometimes it actually helps to put this in a Venn diagram. Okay. Otherwise, you can also look at what you've done here. Okay, you can look at what you've done here. You can see that in the intersection you've got 2 numbers. Okay, 2 numbers. So 1, 1s and the 3s. Actually, let me represent this as a Venn. Oops. So you've got odds, and then this is less than 4. For the probability of, let's do the intersection. I can see that there's 2 numbers. Okay, and then for the odds only, you've got 1, which is just a 5, and then the 4, less than 4, you've got 1 as well. And then that means you'll have 2 numbers on the outside. Sorry, 1, 2, yeah, 4. So you've got just 2 on the outside because this is a dice. So I can see here that you don't have 4 and 6. Yep, cool. So that means you have a 2 in 6 chance of getting a intersection. So that's 1 over 3, sorry. So that means for a fraction, it's going to be minus a third for that intersection. Okay, so a half plus a half is a whole, minus a third will equal 2/3. Okay, if you put that in your calculator, you'll get it as an answer. So that means the chance of getting an odd or less than 4, or less than 4 is equal to 2 over 3. Okay? And that makes sense because in our Venn diagram, if you think about it, if you got 1, I think it was 2, then 1, and then 2 here, and universal is 6, what's the chance of you getting, let's just call this A and B, what's the probability of A union B? It's basically everything in the circle. So it's 4 over 6 over the universal of 6, which is simplified to 2 over 3. So what this basically is, sounds a bit complicated, but it's basically algebra, but in probability. Okay, that's all it is. And there are some answers there again. Okay, that's more or less it. But what I'd like you guys to, or hopefully you guys understood, is what does mutually exclusive event mean again? What do you remember? No similarity, no intersection. Okay? Okay, and how does mutually exclusive events affect the addition rule? Well, remember, with the addition rule, sometimes when it's not mutual, so if there's no mutually exclusive, okay, we take away the intersection, yeah? Okay, I'm going to stop there.